And I would like to speak today about laser drying of printed electronics and battery inks to reduce the dryer length and to improve the carbon footprint, which is quite important. If you do green energies, you should also look into this operation. So that's a summary, short introduction of myself. If you scan this QR code, the presentation will be on later, so completely online. I'm Vice President of Coatema Coating Machinery and responsible for the three technologies we are doing in the company: coating, printing, and laminating. Our focus is equipment, but we also have a big service part. We have a big R&D center in Germany. We're doing public funded projects, specifically European funded projects. And on one of these public funded projects, you will see results today. Our company vision is from lab to fab, and we are definitely working mostly in tech markets like green hydrogen, fuel cells, batteries, flexible solar, third generation, and of course for a long time in print electronics. Some advertising, we're doing slot master classes 4 times a year. We have our own coding conference in Germany, what we are doing. And of course, we have the R&D center where we offer development services. The strong part of our company is our R&D network. All these different names you see here are using our equipment. We're doing with them B2B projects with customers, but also the public funded ones. And here you see an overview on the public ones we're doing at the moment. The biggest one here is Flex to Energy for flexible organic photovoltaics. That's a 25 million funding in Europe on a production line on this with back-end assembly. And we're also working on systems like solid-state batteries, smart window films, solid oxide fuel cells, and carbon capture systems. So we're trying to cover technologies in coating, printing, and laminating, which we can scale up for customers. And why is drying of green energy products a topic? Definitely roll-to-roll processes is always high speed, big working with, and always if you do these coatings, you have to, of course, you have to dry the coatings you put onto a surface. So a lot of technologies come from sheet to sheet into roll-to-roll application to get industrialized. And the advantages are high throughput, versatility, economic viability, and of course, it's perfect for large-scale production. What are the 5 pillars of such a unit? So of course, you have the roll-to-roll web process control. You have to control your ink chemistry, the coating or printing process, the drying process, and today also roll-to-roll inline quality control is getting more and more important. And this means with these 5 pillars, you get a lot of parameters you have to optimize for your process. And if you look into roll-to-roll drying, cross-linking, annealing processes, it's all about dryer design and efficiency. And efficiency means you have to get a dry product before you wind it on. And this can be challenging in a number of industries. If we go deeper into this, you see here a lot of different drying technologies. Today, I'm focusing on laser drying. I will give a short idea why. And the other parameters, of course, play also an important role. Why is drying so important? This research project we did was on drying of battery anode materials. And you see here the cost for this, 27% is drying. So it's nearly the same amount of money like for the dry room operation cost. And that's a big impact if you think about gigafabs, 12 coating lines, using a lot of energy, a lot of cost. Why is this the case? You see here this beautiful picture that's from a German university, so that's the reason for this German wording. This is the old style drying equipment, which is being used in a lot of industries. And if you're drying something, of course, it's a vaporization and removal of water or other solvent from a solution, suspension, or other solid liquid mixture to form a dry solid. Means you have to get the solvent out of the material. You cannot overheat because otherwise you get coating defects. You're destroying the surface you want to reach. And you have heat and mass transfer which limits actually the window of operation or the speed of operation